Hello and welcome everyone to yet another tech enthusiastic video from Simplilearn. Today, we will learn about the most trending topic in the current world of Android development, that's the Kotlin versus Java. Let us wait for an ample amount of time so that few more attendees can join us for this resourceful session. While we wait, how about you subscribe to the Simplilearn's YouTube channel and hit the bell icon to never miss an update on the trending technologies in the current IT industry. Also, if you're interested in learning more about the latest programming languages, then please visit the Simplilearn official website where you can learn more about the latest languages and their trends in the current IT industry. Now, can I get a quick response from your end if we could begin with this session? Great, I can see a lot of replies. Thank you all for your quick response. Now, without any further ado, let us quickly dive into our agenda. First, we will have a briefing about the Java programming language that will enlighten us about its definition, features, and some of the major projects built using Java. Similarly, we will have an introduction with Kotlin as well. After we get good introduction related to both these programming languages, we will then get to learn about Java's edge over Kotlin, where we will understand the capabilities of Java, which make it powerful enough to outrun the issues that Kotlin could not. Similarly, we will also have a discussion about the capabilities of Kotlin that give it a cutthroat competition to Java in some serious performance sectors. Later, we will enter into our main topic for today's discussion, that is the Kotlin versus Java, where we will learn the key differences between the both. Next, we will learn why exactly Google had to switch to Kotlin for its Android operating system. And finally, we will wind up the session by understanding if it's really the end time for Java, or is Kotlin really capable of replacing Java, and which language should you preferably choose for your future. I hope I'm clear with my agenda. Now let us quickly begin with our first topic. That is, what is Java? Putting it straightforward, Java is a general-purpose programming language that is class-based, object-oriented, and designed to have as few implementation dependencies as possible. Java is being the most powerful language since day one and is capable of supporting the development of multiple software applications, operating systems, and even new programming languages. The reason for its outstanding superior performance is its features. The first one among its features are high portability. The compiler in Java is written in ANSI with a clean portable boundary, which is none other than POSIX subset. Having a neutral architecture and no implementation dependent aspects of the specification makes Java the most portable language. Next comes the support for Android. From its official release, 23rd September 2008, Java was the one used to design, develop, and deploy the Linux-based operating system worldwide as the Android mobile operating system. Android uses most of the Java classes and libraries for its use. Next is the most powerful, yet hidden most of the time kind of feature of Java, which is Java's virtual machine. Many call it the JVM as an abbreviation, and JVM is responsible for providing Java its platform-independent nature, which makes it most capable and superior programming languages to run on any computing device regardless of the operating system platform the device is running on. The most important feature that is responsible for choosing Java by most learners and professionals is its simplicity and readability. Java is designed to be easy to learn, and if you learn the basic concepts of object-oriented programming, it will be easier to master. Next important feature is the Java security. Java security enables the development of virus-free, tamper-free systems. Authentication techniques are based on public key encryption. Next, with Java's multi-threaded feature, it is possible to write programs that can perform many tasks simultaneously. This design feature allows the developers to construct interactive applications that can run smoothly. Java's bytecode is translated on the run to native machine instructions and not stored anywhere. The development process is more rapid and analytical since the linking is an incremental and lightweight process. With the use of just-in-time compilers, Java enables high performance. So, this brings us to a question: who is using Java currently and which platforms are developed using it? Well, the list could never end, yet I could mention some of the major platforms. Applications like Uber, Spotify, Instagram, Google, Netflix, and Airbnb are being developed and are in use of Java programming language. Now, let us take a step further and get started with Kotlin. So, what is Kotlin? Released on February 16, 2016, by JetBrains, Kotlin is a statically typed open source programming language that runs on JVM and an official language for developing Android applications. Kotlin basically gets broken down into Java bytecode for compilation, and this caught the attention of many Android developers. Not only this, but there is also quite a few interesting features that Kotlin can support. Let's get going with the features. In many cases, one does not need to use explicit typecasting operators in Kotlin because the compiler tracks the each checks and explicit cast for immutable values and inserts cast automatically wherever they are needed. Kotlin proved that it is highly interoperable as it is compatible with most of the Java libraries and gets transformed into Java bytecode. This allowed developers not to face any troubles while working with Java-based projects. Kotlin is an open source project under the Apache 2.0 license that makes it available on GitHub and is open for community and its support as well. Kotlin is developed by one of the major pioneers in software and IDE development, which is none other than the JetBrains. This makes it trustworthy and secure as it has constant R&D and community support from its giant. The statically typed nature of the programming language makes it less prone to errors as they get rectified most of the time during the compilation stage itself. Last but not the least, Kotlin is considered to be highly efficient due to its concise coding. You can say it reduces like 40 to 50% of the code that you usually type in Java. And most of it was the type of boilerplate code. Now this brings us to know the popular applications developed using Kotlin. Some of the major projects that are developed using Kotlin are Koida, Spring, Telegram, Evernote, Gradle Build Tool, Pinterest, etc. Next in the docket is Java's edge over Kotlin. The first one is the checked exceptions. Java has checked exceptions while Kotlin does not. Examination of small programs leads to the conclusion that requiring exception specifications could both enhance developer productivity and enhance code quality. Without them, the developers observed decreased productivity and little or no increase in code quality. Next is the non-private fields. Encapsulation is essential in any program for achieving a desirable level of maintainability. By means of encapsulating the representation of an object, it can be enforced how callers interact with it. Moreover, it is possible to change the representation without the need to modify callers, provided the public API remains unchanged. Non-private fields or public fields in Java are useful in scenarios where the callers of the object need to change accordingly to its representation. It simply means that such fields expose the representation of the object to the callers. Kotlin doesn't have non-private fields. The next important one is static members and static methods. Now in Android development, things are moving quickly from Java to Kotlin. And one of the biggest problems that developers face while migrating from Java to Kotlin is making a static method. Because in Kotlin, there is nothing such as static. Yes, you heard it right. Kotlin does not have static keyword. If you're an Android developer and you love making Android applications in Java, then you must have used static keyword in your application to make some static variables and static methods and so on. Static variables belong to a class and not its instance. The same is with static methods as well. After static methods and static members, we have issues with primitive types in Kotlin. The primitive data types are most fundamental types in Kotlin. All other types are built on top of the types and arrays thereof. Their representation is very efficient both in terms of memory and CPU time, as they map two small byte groups that are directly manipulatable by the CPU. And this type of issue is not faced in Java. Lastly, the support for ternary operator. Java has the ternary operator support, which most of the time helps to decrease the code length in simple terms. This is not available in Kotlin. Now, without the support of static methods and ternary operator, you might have a tough time developing. Now, let us learn the Kotlin's edge over Java. One of the most common pitfalls in many programming languages, including Java, is that accessing a member of a null reference, which will result in a null reference exception. In Java, this would be equivalent of a null pointer exception, or NPE for short. Kotlin's type system is aimed to eliminate the null pointer exception from our code. Not only this, the only possibilities of NPE may be an explicit call to throw null pointer exception or the usage of exclamatory or not operator. Next is the separate interface for readable and mutable collection. The Kotlin standard library offers generic interfaces, classes, and functions for creating, populating, and managing collections of any type. The collection interfaces and related functions are located in Kotlin.collections package. The Kotlin standard library provides implementation for basic collection types, sets, lists, and maps. A pair of interfaces represent each collection type: a read-only interface that provides operations for accessing collection elements, and a mutable interface that extends the corresponding read-only interface with write options. Followed by that, we have the companion objects. If you need to write a function that can be called without having a class instance, but needs to access to internals of the class, for example, facade method, you can write it as a member of the object declaration inside that particular class. Even more specifically, if you declare a companion object inside your class, then you can access its members using only the class name as a qualifier. Next ahead, we have the first class delegation pattern. The delegation pattern has proven to be a good alternative to implementation of inheritance, and Kotlin supports it natively requirement 0 boilerplate code. A class derived can implement an interface base by delegating all of its public members to a specified object. Followed by that, we have the operator overloading. Kotlin allows us to provide implementation for a predefined set of operators on our types. These operators have fixed symbolic representation like plus, star, etc., and their precedence is fixed. To implement an operator, we provide the member function or an extension function with a fixed name for the corresponding type, that is, left-hand side type for the binary operations and argument types for unary ones. Functions that overload operators need to be marked with the operator modifier. Finally, we have the primary constructors. A class in Kotlin can have a primary constructor and one or more secondary constructors. The primary constructor is a part of the class header. It goes after the class name and optional type parameter, and if the constructor does not have any annotations or visibility modifiers, then the constructor keyword can be omitted. The bottom line is, Kotlin made the use of constructors more simplified. With this, let us move ahead into the next topic, which is the Kotlin versus Java. The first parameter that we will be discussing is the speed. Java compilation time is 15 to 20% faster than Kotlin compilation time, but the perspective of the incremental build compilation, Kotlin will also take the same compilation time as Java. Next is the null pointer exception. In case, if you intentionally declare a null value, then the Kotlin code will be collapsed while compilation. Whereas on the other hand, in Java, the null pointer exception is the biggest nightmare for Java programmers. After this, we have the extension functions. Kotlin provides developers the ability to extend existing classes with new functionality. We can create extend functions by prefixing the name of the class to the name of the new function. While on the other hand, in Java, if we want to extend the functionality of the existing class, then we need to create a new class and inherit the parent class. So extension functions are not available in Java. The next major difference is the casting. In Kotlin, the smart cast will handle these casting checks with keyword isChecks. This will check for immutable values and perform implicit casting. While on the other hand, in Java, we need to check the type of the variables and cast according to the operation. In other words, it is completely manual. Next ahead, we have the checked exceptions. In Kotlin, we don't have checked exceptions, so developers don't need to declare or catch the exceptions which have advantages and disadvantages. While on the other hand, in Java, we have checked exception support, which makes the developers declare and catch exception, which ultimately leads to robust code with good error handling. Later, we have the language type. Kotlin is a mix of procedural and functional programming language, which consists of many useful methods such as lambda, operator overloading, higher order function, and lazy evaluation, etc. While on the other hand, Java does not have the functional programming support till Java 8, but while developing Android application, it supports only subset of Java 8 features. Then we have the data types. In Kotlin, we don't need to specify the data type for each variable explicitly, as the assignment will be taken care by Kotlin internally. While on the other hand, in Java, we need to specify the type of each variable explicitly while the declaration stage. And lastly, the getter and setter methods. In Kotlin, if we need to have classes which needs to hold data, we can declare a class with keyword data in class definition. Then the compiler will take care of all this work such as creating constructors, getter, setter, etc. While on the other hand, in Java, suppose we need to have a class which need to hold the data but nothing else. For this, we need to define constructors, variables to store data, getter and setter methods, hash code, string, etc. functions, which is completely manual. With this, we shall now move into our next topic where we will discuss about the Google switch to Kotlin. There were several reasons behind the incident where Google had to switch from Java to Kotlin for its Android operating system. But let us discuss some of the important ones. First, Android needed something more precise and concise in order to express new ideas and execute them accurately. Kotlin's modern language features allows you to focus on expressing your ideas and write less boilerplate code. Next is to achieve safer and more reliable coding platform. For instance, let us consider the null pointer exception. Kotlin introduced a way to improve your app quality with add nullable and add non-null baked into its type system. Kotlin helps to avoid costly null pointer exceptions. Followed by that, we have the interoperability. Google had to switch from Java one or the other day. It is obvious that the latest technology may become obsolete one or the other day. Similarly, Java. So Android was looking for one such platform which could support its empire. Kotlin is 100% interoperable with its Java programming language. So you can have your project shifted to Kotlin with least effort. Next is the efficiency. Kotlin asynchronous programming, making most common tasks like network calls, database updates, the simplest and performant. Last but most importantly, Google had to make this move as Oracle acquired Java and commercialized it. Google had to get rid of Java sooner or later. Since the time Oracle took control of Java and observed Google's use of Java API in Android, it has been bombarding Google. The lawsuit was about the commercial use of Java API. Oracle goes for appeal against Google and Oracle won. So Google had to switch from Java to another programming language. Now comes the question of the session. Can Kotlin really replace Java? The answer is obviously a big no. Kotlin was built to incorporate with Java. Kotlin was just a fix to Java's tedious problems in Android development, but not to replace Java as a whole. So you might have many questions right now about everything. One common question is, which programming language should you choose? So if you are the one who is going to start your career with the following technologies such as mobile applications, server-side and client-side applications, data science, etc., then having a sound knowledge of Kotlin would be an added advantage. So on the other hand, when it comes to Java, Strictly anything you want to do needs Java. So if you are thinking to begin your career with these fields mentioned below, that are Java web applications, scientific applications, software tools, big data, etc., then I suggest you go with Java. Now with this, we come to an end of this session on Kotlin versus Java. I hope this session was helpful. If you have any queries based on this tutorial or any questions related to Java or Kotlin, then please feel free to drop them down in the comment section below, and we will have your questions answered by our experts as soon as possible. It's Ravi signing off, and don't forget to get subscribed to our channel and hit the bell icon to receive important updates on the trending technologies. Thank you. Until next time.